email or pull up a web page, millions of invisible operations are happening in the literal blink of an eye. So today, we're going to map out exactly how that digital magic works by breaking down the framework that makes global connectivity possible. To get there, we'll be following a single package of data through 6 key steps. We'll start with the blueprint of the internet, then cover preparing the package, addressing and routing, mapping out the physical journey, unpacking the data, and finally, I'll share a really handy OSI memory trick to help you retain the whole shebang. All right, part 1, the blueprint of the internet. So what exactly is this framework? Well, it's the OSI model, or the Open Systems Interconnection model. It was developed by the International Organization for Standardization, and it basically slices up network communication into 7 distinct layers. Think of it like a massive global courier service. If you want to ship a fragile package overseas, it goes from you to a local facility to logistics planners, and then finally onto a cargo plane. In the digital world, each of these 7 layers performs a very specific task before handing your data off to the next layer down the line. And here's a really crucial takeaway. Even though modern networking relies heavily on the simpler TCP IP model to actually run, this 1984 OSI framework remains the ultimate universal diagnostic tool for engineers worldwide to pinpoint exactly where a connection is failing. Moving on to step 2, preparing the package. Our courier's journey actually kicks off right at your screen, at layer 7, the application layer. This is the layer that's closest to you, the user. When you open up your web browser or send an email, your application is interacting directly with this layer using protocols like HTTP or SMTP. Once that data is generated, it gets handed down to layer 6, the presentation layer. Think of this as your security and formatting checkpoint. Say you're sending a secure photo, this layer actually compresses the file to shrink its size and encrypts it so nobody else can snoop on it. After that, we hit layer 5, the session layer. If you're on a video call, for example, this layer creates, manages, and eventually closes out the active session between your device and whoever you're calling. Oh, and for these top 3 layers, the data unit we're working with is simply called, well, data. Which brings us to section 3, addressing and routing. Now that our digital box is packed and secured, layer 4, the transport layer, presents a really critical choice for your data, TCP or UDP. This layer is all about end-to-end communication, and it turns our data into a segment. On one hand, you have TCP. This is basically your certified mail. It is highly reliable, it checks for errors, acknowledges receipt, and it will actually retransmit any lost data. It's exactly what you want when you're downloading a file, and absolutely every single piece needs to arrive flawlessly. On the flip side, you have UDP. Now, UDP completely sacrifices guaranteed delivery for pure, unadulterated speed. It doesn't wait around for acknowledgements. And actually, that's exactly why your character might suddenly teleport across the map during a laggy gaming session. Because in that scenario, a dropped frame is way better than a delayed one. Dropping down to layer 3, we hit the network layer. This acts as the master logistics planner for our journey. Just like a courier uses a map to pick the fastest highway for a delivery, the network layer determines the absolute best logical path for your data to travel. It does this by relying on IP addresses and utilizing hardware called routers. So with IP addresses acting as your global zip code, your segment has now been given its official routing instructions and becomes what we call a packet. Next up, section 4, the physical journey. Okay, before a packet can actually leave your local office network, it has to navigate layer 2, the data link layer. While layer 3 is busy getting data across the world using global IP addresses, layer 2 is responsible for transferring data between devices on the exact same local network. It pulls this off by framing the data and stamping it with a physical MAC address. That hard-coded identity ensures that local network devices, specifically switches, know exactly which computer or server to bounce the information to. And at this level, our data unit is officially known as a frame. And finally, we hit rock bottom, in a good way. Layer 1, the physical layer. This is where the digital world literally becomes the physical world. This layer takes our frame and converts the whole thing into raw bits, ones and zeros that are represented by electrical, optical, or radio signals. It's at this bare metal level that your email is broken down into millions of electrical pulses, or beams of light, shooting across continents at nearly the speed of light through physical cables and hubs. All right, part 5, unpacking the data. As we've just seen, when you send a message, your data gets wrapped up tighter and tighter as it travels down the layers. This process is called encapsulation. The application, presentation, and session layers create the data. The transport layer wraps it in a header to make a segment. The network layer wraps that in an IP header to make a packet. The data link layer slaps a MAC header on there to create a frame, and the physical layer instantly converts it all into bits. Your data is effectively tucked inside a set of nested digital envelopes in a fraction of a millisecond.
But here is the absolutely crucial point. On the receiving end, the exact reverse happens. The receiving physical layer catches those raw bits. The data link layer reads the frame and strips away that MAC header. The network layer checks the IP address and pulls off its header. The transport layer takes the segments and pieces them back together. The session layer manages the active communication. The presentation layer decrypts and decompresses the raw data. And finally, the application layer presents that photo or email or web page right there on your friend's screen. This backwards process of unwrapping the headers layer by layer, that's called decapsulation.
And finally, Section 6, the OSI memory trick. Look, if you ever need to troubleshoot a network issue, or honestly just want a foolproof way to remember this entire architecture, memorize this one simple phrase: all people seem to need data processing. If you can just remember that sentence, you will perfectly recall layer 7 all the way down to 1. Application, presentation, session, transport, network, data link, and physical, every single time. This quick summary perfectly captures the entire ecosystem we've explored today. But rather than just rattling off facts, think about the real-world application here. If you're ever trying to fix a network, let's say you have a faulty router, this framework instantly tells you to start looking at layer 3. If it's a switch acting up, you check layer 2. It shows exactly how data transforms from user applications into segments, packets, frames, and bits as it interacts with highly specific hardware. It is literally a highly orchestrated diagnostic map of our modern world. So I'll leave you with this to chew on. The next time you stream a live video or send a highly secure photo across the globe in less than a second, which OSI layer do you think is working the hardest to deliver your digital package? Is it the raw speed of the physical layer, the brilliant logic of the network layer, or maybe the encryption at the presentation layer? Keep that in mind the next time you hop online, and until our next explainer, keep wondering about the incredible hidden logistics right behind your screen.